variable, and one other thing. The coefficient does not have to match, but the variable and the exponent, right? If you want to combine x squared and x squared, great. You have two x squareds. But you cannot combine x squared and x to the third and get 2x squared x. You can't do that. Like that's not mathematically correct, right? So we're going to be talking today about ordering, adding, and subtracting polynomials. Okay, so let's go ahead and put today's date, Thursday, February 8th, and we're doing polynomials, ordering, adding, and subtracting. Yeah, that's why I have a 24 there. Huh, weird. There's a 4 for 24. It's crazy. Okay, so let's see here. There is a rule for ordering. Okay, polynomials. And this rule is not going to make sense until we start doing it. So you're going to be like, what does that even mean? What is that? And then, but once we start practicing it, you'll be like, that's easy. Okay, that makes sense. Okay, so you must order from greatest to least by degree. And you're probably thinking, okay, I understand ordering greatest to least, but what on earth does the word degree mean? So we have this expression here, 6x to the 4th plus 7x to the 8th minus 9x to the 3rd. Okay? This is a polynomial. This right here is the definition of a polynomial. We have terms that have exponents and variables. We also have some coefficients. What are my 3 coefficients for this polynomial? 6, 7, and negative 9. Yep. Right, that negative is attached to this 9, right? It's part of it. Okay, so when I say you must order polynomials from greatest to least by degree, and some of you are thinking, well, what is a degree? Exponents are the degree, right? So if I want to order these from greatest to least by degree, the term that has the highest exponent needs to be moved to the front. The term with the next highest exponent would be moved to where it needs to go. And it doesn't matter what the coefficient is, it's just we're looking for the terms that have highest exponents down to the lowest exponents. Except now we're referring to exponents as degrees. Okay, so if I were going to rearrange this, which is what we do when we are ordering exponents, what would be my first term? Judah? Yep, 7x to the 8th. What would be my next term? Plus 6x to the 4th. And then I'd have 9x to the 3rd. Yes. And you just have to trust the process. The reason we're doing this is because down the road you will want them in this order so that you can actually factor them, which don't get hung up on that word, but we will be factoring polynomials. Yes?
Why do we change the word exponents to degree?
That's just what happens when you start talking polynomials.
Wait, is this the answer?
This is our answer.
Wait, what?
We are ordering. Right now we're just ordering.
Oh,
This is the first part of our notes. Ordering, and then we'll get to adding and subtracting. Okay?
Every single
Let's do another one. Now, most of you are probably thinking this is ridiculous. It's not that difficult. The only mistakes I ever have students make is they forget that the negative here goes with that 4 no matter what, right? The sign in front stays with it, right? Now, this 5x doesn't have a symbol, but what do we think, what would we say it is mathematically? It's a plus, right? It's a positive. So if you have to move this, then wherever you put it, you put a plus sign in front of it. And we know it's a plus because it's not a negative. So that's where that, it's the deductive reasoning, right? So if I was going to put these in order, what would be my first term? What would it be? Madison? You're so close. You're so close. Connor? Negative 4x to the third, right? That negative stays with it. What would be my next term? What would it be? Connor? Yep, plus 2x squared. And then what's my last term is going to be the plus 5x, right? So remember, we're looking at the degrees. What degree is hiding here? A secret 1. So if there isn't a degree, you know that it's a 1, okay? And if you want to write that in, I suggest you do that. Okay, let's do one more. Go ahead and do this one by yourself. This is a 4. I know it's kind of hard to see with the glare. Hold on. There we go. Okay. So remember, the degrees are talking about the exponents, so that we're not taking into account the coefficient. So what would be my first term? Nora? Negative 6x to the 9th. What will be my next term? Christian? Negative 8x to the 4th. And then this 10x just hangs out where it was. Okay, so that's ordering polynomials. You put them in order by the degree, and we all just learned today that degree means exponent. Okay, second page. We're going to show our adding and, we're going to show our adding and subtracting rules. So exciting. All right, this is where you need the colored pencils. If you weren't able to get some, maybe you can share with the person you're sitting with. Okay. So let's talk about adding polynomials. Whole new page. Whole new page. We're going to have adding and subtracting on the same page.
Okay. To the back.
Okay. Two x to the third minus 5x squared plus x plus 2x to the third plus x squared minus 1. Okay, when we are adding polynomials, you can only combine them if they have the same exponent and the same variable. So right here, I can see that I have 2x's to the third and another 2x's to the third. I can add those because they both have the same variable and exponent. So how many total x's to the third do I have? 4. 2 plus 2 is 4, right? So I have 4x to the third. I'm going to go ahead and color code that as well. So you're like, where did that come from? Oh, this 2x plus this 2x. 2x to the third plus 2x to the third. I have a negative 5x squared and then a positive x squared. So how many x's squared do I have? I have negative 4x squared. And then I have an x. Do I have anything else that just has an x? No. So I can't combine that with anything. So I would just bring down the x by itself because nothing combines with it because I don't have anything else that is just an x with no degrees, no exponents. And then I have this positive 1 also just hanging out. I don't have any other constants. So I just get, negative 1. So then I just have a negative 1 as part of my answer.
Okay. Miss Ross, do we have to order them?
Eventually, yes, you will need to order them. Like right now, these were nice and neat and in order for you, right? But these are already in the order they would need to be in.
Okay.
If they weren't, yes, you would have to rearrange them. Okay, so we're looking for like terms, right? A like term is same exponent, degree, same variable. Okay, and then you just combine them like you would. 2 of these plus 2 of these gives me 4 of them. Negative 5x squared plus 1x squared gives me negative 4x squared. Right, so we're combining like terms. Those terms have very specific requirements to be considered like terms. Let's try another one. Okay, so I'm going to be looking for the highest degree. What is the highest degree in these terms? Right? Does anything else match up with the 5n to the third? Nope. So I'm just going to color that red, and I'm just going to write down here 5n to the third, because it doesn't combine with anything. Right? Bless you. What's my next highest degree? Sure. I have 4n to the second, and I also have a negative 7n to the second. So how many n's to the second do I have? Negative 3, right? You go left to right, or even if you're just combining them, you would have negative 3n to the second. Notice I'm not changing the degrees when I combine. I'm only affecting the coefficients. What's my next lowest degree? 6n. Does it have anything it can be combined with? Nope. So I just bring down the plus 6n. And then we have another lonely coefficient, this plus 5. So that's adding polynomials. Pretty straightforward stuff. Subtracting isn't that much different. There's just a little step we have to do before we can start combining them. Okay? So we'll get started on that. Like and subscribe.
I am.
Are you recording right now?
I am. We have like 6 people absent. So this is the best way to make sure they can get the information. Didn't I tell you guys I did that for like 2 whole years? I think I told you that, didn't I? Yeah. Every lesson I recorded. Not with every class. I picked a class a year where I was like, this class would be good to make recordings. Yes.
All were good class?
Well, this is, you guys are like the calmest of the day. And then if I had like to make one for pre-algebra, it would probably be 4th period.
The calmest of the day?
Yes.
I think it's so early.
It should not be. You guys do a great job.
What about 5th period?
Zach,
It's crazy.
come on now.
You have quarter, Dave, and
Did you have a question, Christian?
So it's not math. I was just like wondering, and it just came like to my head. Like, what's a leap year? Or, like, what's
So I can give you like the technical
Now we're not
thing.
the best. What?
So,
I know what it is, but like,
So
how's that?
every 4 years they add a day, and that's because I've actually watched Neil deGrasse Tyson explain this. So basically, it takes longer than the 365 days a year for the Earth to do its whole year rotation. A little bit longer, right?
Every 4 years.
But you don't want to like randomly add on like 2 hours here or 2 hours there. So they figured out mathematically it takes about 4 years to add up to a whole day. So every 4 years they just throw in an extra day to make up for that tiny bit of time that we gain over those 4 years. So like we don't notice it.
And it's
Right?
29.
So then half is
So it's 6
What if you're
years,
born
6
on leap
hours
day?
every year.
If you're born on leap day, you're probably like 6 years old.
Then you just plan. I mean, you celebrate. Like you celebrate on the 28th or on the 1st. Yeah.
You never have your real birthday till before you.
Able to drive, or did they?
I mean, yes, you can. They accept that you were born on a
Yeah,
leap
I
year.
just wanted to born on leap day.
Okay. Does that help?
Yeah.
Okay. Okay.
Yeah, I meant like born on the leap day. I don't know why people say L. I just think born on the leap day.
What size is
Then he's
that?
bald. I swear to God, he's bald. He's like 7 years old.
That's not my size.
Leap day off.
Guys, in between this minus sign and the parentheses, leave a little space right here. Like I put that there on purpose. Okay. Okay, so we're still going to be paying attention to the degrees and the variables to determine what we can and can't combine, but we do have an extra little step, okay? This negative applies to all of these terms. So we have to distribute the -1. And by distributing the -1, we are now turning it into an addition problem. So we'll have 4x squared minus 3x plus 5 plus negative 3x squared plus x plus 8. Okay? So by distributing that, we now have an addition problem, but you still have to like signal that yes, this is a negative 3x squared. Yes, this is now a plus x, and this is now a plus 8. Okay? So now we can combine, and we have what looks like a 4x squared and a negative 3x squared. So how many x's squared do I have left?
1x.
Yep. You can just put x squared. You can put 1x squared. It's up to you.
Can I get water with mine?
Yeah. Okay. Now we have some x's. We have negative 3x plus x. So how many x's do I have? Negative 2 x's.
You say yes.
And then we just have a couple constants hanging out here. We have plus 5 and plus 8. So how many?
13.
I have 13.
Why don't
Nope.
we solve it?
We're not doing anything with them right now. We're just adding and subtracting. Trust me, Grady, there's plenty of time. Plenty of time for solving. Yes?
How do we know that the x's come before the 13?
Because the 13 doesn't have a variable, right? So it's not being multiplied or by times anything, so it's automatically the least degree you can have. Okay, one more example, and then I'm going to give you guys your assignment.
Practice problems!
4m squared plus 2n minus 3n squared minus 5n plus 6n squared plus 3m squared.
Are you just making like the numbers?
Nope. Nope, I got these from a book at some point, and so then I just have what I did last year, and I use them over and over, because, I mean,
You ever get bored of doing it over and over again?
nope.
You should be one of those teachers that have like a TikTok account and you're like a teacher TikTok person.
As much as you should be one of those TikTok teachers.
I mean, I do have TikToks, but they're
Yeah,
not,
you should be.
they're not, like, informative.
You should be one of those TikTok teachers. Miss
A
Brooke.
TikTok
Yeah,
teacher?
the ones that would record during like
Can we
class
follow
or
you on
whatever.
TikTok?
Sure, I mean, it's just, like, videos of people trading shoes and things. Like, it's just silly stuff that 8th graders do.
Exactly. Kind of backing up my idea.
Okay, the first thing we need to do is distribute this -1 if you have not already. Right, that -1 is hiding there. So we're going to end up with 4m squared plus 2n minus 3n squared plus -5n minus 6n squared minus 3m squared. So we've got some n's and we've got some m's. Mhm.
Wait, can you pause for a second?
Sure.
This is so easy. I think we should just move on. So much writing and writing my brain.
Sorry.
Judah?
Do we combine the like terms that are within the same set of parentheses?
There's
There are none that are the same.
Well, just if there ever were.
If there were, yeah, absolutely.
really
Okay.
harder.
So when you have the same letter, like when you have different letter variables, what do you think you might do to order it?
So that's
Alphabet.
Alphabetical, right? So do you see how we have m squared and we have some n squareds? So if I was combining my like terms and putting them in the proper order, I'm going to combine the m squareds first because m comes before n in the alphabet,
I don't know the alphabet.
right? So I've got 4m squared and I've got -3m squared. So how many m squareds am I going to have?
M squared.
1. Then I've got -3n squared and -6n squared. So how many n squareds do I have? -9n squared.
I said, I quote, please.
Right? And then I have +2n and -5n. So what am I going to be left with? -3n. Green.
We're doing the practice. Do we have to use
Wait, how do you know that?
You do not, however, I would encourage you to do that to keep track because it can get real confusing. Okay, so that's the end of the notes. Keep them out. Do not put them away. I want to take a couple seconds to talk about the practice that you guys are going to do. Okay, I want everybody's attention because inevitably someone's going, nope, sit down, keep it, no, sit,
Yeah, sit down, buddy.
sit.
Hey, you hit my binder.
Okay,
It's a hazard being in the walkway though.
now here is what the practice looks like.
What the?
Okay, let's talk about it. Let's talk about it.
Oh, are we just showing the steps that we used to get the
Nope. Nope. I'm going to zoom in on this so you guys can see what's happening.
Oh, okay, that makes sense.
Okay. So it's kind of like a bracket, right? We all know in Indiana what a bracket is. Okay. So I did the first one for you where you would combine these. Please, please, please pay attention to the addition or subtraction. Okay? I highly encourage you, number 1, to rewrite these problems on a separate piece of paper. And number 2, to color code. I can't force you to do either of those things, but I would highly encourage you to do that. Okay? So when I combined these, right, I got this answer. When you combine these, you're going to get this answer. You're going to use both of these answers to get this answer. If you make a mistake in any of these, what do you think is going to happen for this one?
Make a mistake in that.
Also going to be wrong. Right?
Don't make a mistake.
Don't make mistakes. That's why I'm highly encouraging you to write them on a separate piece of paper and color code. Okay? Because if you make a mistake on number 5, that is going to affect several different answers, right? Mistakes here are going to affect here, is going to affect here, and it's going to affect here. So your goal is to make sure you have the final answer correct. There's also a bracket at the bottom. Okay? I know, this is exciting. There's only 15 problems. Okay, I numbered them, so if you have a question, you can tell me which one, you come up and we know exactly what one you're working on. Okay, and then of course you have the pluses and minuses that you really need to pay attention to. Are there questions about this assignment? Nope. Okay, I'm going to pass this out. If you would like to either put your colored pencils away, which I don't approve of, but can't do anything about, or grab lined paper.
I'm colorblind as well, so.
Are you really?
Yeah, well, it makes no sense for me to color code.
Are you just telling me that? Or are you really colorblind?
Yeah, you can ask my mom.
Huh. Well, I won't do that. I won't fact check you.